Good evening, friend. In the last few lectures, we have studied the chapter UV visible spectroscopy. In that, different laws are studied: Lamberts law, Beer's law, Lamberts-beers law. Now, this is a lecture which deals with the study of Lamberts-beers law. What is statement of Lamberts-beers law? What is the expression for the Lamberts-beers law? So this equation very useful in determining the absorption measurements. So we are going to learn Lamberts-beers law, combined form of Lamberts-beers law. According to Lamberts-beers law, now the Lamberts-beers law is nothing but the absorbance is directly proportional to path length and concentration. So that is the statement of Lamberts-beers law. Absorbance of the solution is directly proportional to path length and concentration of the sample or sample solution. So that is a statement of Lamberts-beers law, a combining statement of Lamberts-beers law. Now, according to Lamberts law, we have already studied the Lamberts law. It is equal to I0 10 raised to minus kb. So this is the equation first. So it is equal to I0 into 10 raised to minus kb. Now the Beer's law is given by the equation it is equal to I0 10 raised to minus kc. This is the equation number 2. Now Lambert's law gives the information about the thickness or path length of the sample, while Beer's law gives information about the concentration of the sample solution. So that is the most important difference between these two laws. And the combining statement, that is nothing but the absorbance of the solution is directly proportional to concentration and thickness or path length of the sample solution. Now combining this equation 1 and equation 2, we can write the equation it is equal to I0 10 raised to minus abc. Now here k is replaced by small a, where a is absorptivity and it is related to constant. Taking log on both sides, if you take log on both sides, it upon I0 is equal to 10 raised to minus abc. So if you take a log on both sides, log of it upon I0 is equal to minus abc. Now 10 will be get cancelled naturally. So log of it upon I0 is equal to abc. Now here negative sign is absorbed to the left hand side. Log of it upon I0, that becomes log of I0 upon it in this line. Log of I0 upon it is equal to abc. Now abc is nothing but where a is the absorptivity or absorption constant, b is the path length, c is the concentration of the sample solution. Now I0 is the intensity of incident light, it is the intensity of transmitted light, and it is the ratio. But now a is equal to log of I0 upon it. Now absorbance is defined as log to the base 10 of intensity of incident light to intensity of transmitted light. So it is the ratio. Therefore, this equation becomes log of I0 upon it is replaced by capital A. Capital A is equal to small a into b into c. When the path length is expressed in centimeter, this is the most important significance. When the path length is expressed in centimeter and concentration is expressed in mole per liter, at that time capital A is called as a molar absorptivity. That is a molar absorptivity, and it is indicated by the symbol epsilon. This is the epsilon. Therefore capital A is equal to epsilon b into c, small a replaced by epsilon. So that is epsilon is nothing but the molar absorptivity. So that is the Lamberts-beers law. That can be this is the equation for the Lamberts-beers law, and that Lamberts-beers law is finally put forward in different equations. Small capital A is equal to abc, that is equal to log of I0 upon it. So log of I0 upon it is nothing but the naturally capital A, that is absorbance. Now if we remove the negative sign, I0 becomes it and it becomes I0. So naturally numerator becomes denominator and denominator becomes numerator. So is equal to minus log of it upon I0 is equal to log of t, capital T. That is, capital is nothing but transmittance. So capital T minus log of it upon I0 is equal to minus log of t is equal to log of 1 upon t. So this is nothing but this total equation of line is nothing but the different form of Lamberts-beers law, and we have already used in different problems. So with this content I conclude this lecture. Thank you very much for patience listening.